This is All the Ideas with Madfellows and the Madfellows Tech blog. Joining me today, I'm Dan Servo and Douglas Bebb and Rick Anderson. Me and Rick are both co-authors of Pro Arduino. And it just got released today, so very kind of special episode.
Yes.
So, and any thoughts on the whole, year and a half of writing this book?
Oh my gosh, that was it was a project all the time. So definitely, I'm incredibly excited that we got it out the door. It took a lot of energy to get in there, and I think that I'm just excited to sort of see what people do and how they respond, and be there to support the people getting started with sort of the advanced stuff with Arduino.
Yeah, no, that definitely, that was the fun part, I thought, was trying to figure out, how do we go from what's out there to the next level with these things.
Mm-hmm.
So,
I mean, that's sort of the way the table of contents came about, was like working on a bunch of projects, working with my friends at Foobar Labs, which I'm actually at Foobar Labs here. And it was sort of like, okay, well, what kinds of projects, what kinds of things we're looking at doing, and we just workshop, just based it off of reality. Like, these are things that people really got started, needed to do something as a follow-up.
Yeah. So, well, on the special end, I'm actually going to open the box for the first time of the copies they sent us. So this ought to be fun.
Cool.
Oh. I see they shipped us small calendars. I don't know if your box said that or not.
Well, maybe your books are larger than mine. Like poster-sized.
Poster-sized books. I'm surprised they just didn't walk it to you, across the bridge.
Well, there could be a special launcher.
Ooh.
We can set that up with some Arduino-powered tube or something.
So, is it like the Domino's pizza delivery with the quadcopter?
Ah.
So, for those of us,
I think with air regulation, though, FAA might take issue with anything launching.
Well, at least certainly things landing around Foobar Labs is an issue. We're right across from the train tracks. So Amtrak.
That might be misinterpreted.
Yeah. Yeah. Oh, look at that. Those are books.
These are books. Those of you just listening to the audio, we're unpacking books right now.
Definitely losing a little visual appeal here.
Yes.
Yeah.
So, there it is. Pro Arduino, Rick Anderson, and Dan Servo.
Yes. You got your copy over there too.
That's right. You just handed it over right through the web.
Yes. Portals.
Oh, and actually,
wormholes.
I've got the fun inverted camera. I don't know if that's running for you too, but I'm actually in the mirror universe.
Okay.
At least in my own camera.
Okay. So normally you don't have a beard, right?
That's right.
No, I can correct stuff. So we have the technology, but this is definitely a nice feel. I mean, this.
Yeah.
I can't believe it's out.
I really like giving these to people too. It's really awesome.
I'd like to just ask a couple questions if you got a little 20 questions here.
Oh, sure.
For you, Rick, what was the most difficult chapter that you worked on? What made it? What was the biggest technical challenge that you had in writing your sections of the book? And you can tell us a little bit about what sections you did write.
Oh yeah. So I my goal was to sort of find ways to use how do you, now that you've done your own individual sketch, how do you go and make a project out of it? How do you get other people to share it? For instance, how to put it on GitHub, how to do version control. And then projects that get bigger, there's always a problem, right? So you want to know how to manage problems, and GitHub has an issue tracking and how you keep track of your code. And for me, actually, that instead of being difficult, that was the fun chapter, because I love that project management level and how things work together and how you get people together in projects. So this is just one of the things that I ended up really enjoying. Two things in terms of technically really interesting and somewhat challenging was in the Arduino test suite chapter. I actually went through, and Arduino has the SPI library, but it doesn't have a doesn't have a slave mode or something for your device. but
Yeah.
you can put the Arduino into slave mode. So the idea was to test it out and figure out that can this work or not, and use a real world question and get that real world question into the Arduino test suite chapter. And so once I got it structured, things started coming together, and then each of the variations on the theme for the tests all started to work out. But getting that concept was really kind of tricky in the first place, and I owe a lot to the internet and good grief. I need to look up the person, but I haven't cited in the book, but there's a guy down in Tektronix or something in Australia. So anyway, he did an analysis of the SPI at the oscilloscope level, how it worked. So using that input, crossing it with the Arduino test suite, that worked out really well.
Okay.
Yeah, so that was really tricky. There was another one in the what was the chapter? I did a kind of a double packed chapter, kind of double stuffed. It was the PIC32 chip kit boards crossed with the ATtiny environment. So one was a secret knock type project, and that wasn't too tricky, but that was again based off of a knock gumball machine project, and sort of using the open source stuff and talking to the developer of that project and saying, hey, this is really cool, I'm doing a secret knock box, and then working that example out. So that was trying to fit that onto an ATtiny 85. So it actually worked really well, but that was like, how do you take what is typically a large program and put it on a device that costs like $1? And so that was a key thing.
And I think that's going to be a really good resource for people to be able to do, to be working on different boards than just the standard Uno or the Mega. So
yeah, exactly. Because once you start working with those boards, you're like, okay, now I want to do, like in my case, I was doing Morse code, and I wanted to make a block per character. And it turns out, well, you need 26 blocks. Well, 26 blocks times $35 for an Arduino Uno, your budget is blown.
Well, yeah, that would.
So I'm like, oh my gosh, I got to find a cheaper way to do this. So what I did was look at it and go, okay, the ATtiny's in quantity are only like, a little under $1. So hey, now I can make my Arduino on a breadboard, and I can make it really cheap, and I can fit that inside of a teeny little box with the right amount of power.
Yeah.
So,
oh yeah, your little kid blocks.
Yeah, the little alphabet.
Yeah, the alphabet thing. That was I saw that when you were down here last.
So it was really fun. So what I did was the example in the book is the guts of the project. So you see, if you do the knock sequence, you'll see the servos move, that kind of deal. And then as it goes, you can put those guts into your own projects. And it's also nice because I used the servo example. A lot of people have trouble with that on the ATtinys, and I show people how to do it as a manual pulsing the servo. So like if the library isn't available for you, you don't have memory for it, you just manually control the servo.
Yeah.
It's awesome in that regard. So it's like, if the library is not working for you, you can just do it manually and it will work, and here's the formula for it.
Yeah, that's definitely the interesting trick with like the Arduino itself and its timer structure. I mean, the Uno only has 3 timers available, and one of them you can't really use if you're wanting to use serial or something else. Yeah. So you kind of have to dig into the code if you want to do some really advanced stuff with just the Arduino. Outside of the IDE, go to kind of the Amtel thing.
Yeah. Well, as soon as you do GPS over serial and then servos, that serial data starts tweaking the timer that's attached to your servo.
Yeah.
And you get jitter and jumpiness in the actual movement.
Yeah, I'll have to try that with the Saab, the multiprocessing.
That would be really cool. I would love to see that.
Then,
can you tell me more about the Saab library? Because I think that's one of the neat technology outcomes.
Yeah, I think Doug can cover that one. He did a lot more work on it. I mean, I know when we were first, kind of your thing about the SPI, we ran into a lot of resistance on the internet trying to find information. And it just came down to, we had to mess with it ourselves. People were like, what you're planning on doing with this is impossible. Like, you cannot do that. And we have it in books. So I really got to thank Doug for being able to do that for me.
Yeah, I think that particular project was pretty exciting that I got to work on it because it was kind of uncharted territory. Getting the slave SPI to work was definitely a bit of a challenge, but there was at least some resources out there on the internet that I was able to use. But I did actually sit down with my O-scope, and I'm working with it and working out the reliability issues. Finding some information that's not even in the Atmel data sheets pertaining to their line speeds, everything that probably missing from the data sheet. But then when I started working on the Saab project, trying to create an actual bus architecture that uses no master device, we ran into a lot of resistance from a lot of the strict AVR programmers, and I didn't find anything in anybody who's dealt with Arduino that, pretty much everybody was telling me, no, that is absolutely not possible to make something function that way. So it was really exciting and a little hair-pulling for a lot of the process to making it happen. I mean, I think we both wondered if it was possible, even at a time or two. But when we got it working and it was reliable to a point where every time you did this would happen. And it was very consistent to that. All the benefits of that architecture really, that was for me the most exciting part of the book to see come together. But that's also the part I had the most involvement with on the book.
I think the readers will be quite pleased to know that we did not have to include assembly language. We came close, but we did not have to include assembly language.
Yeah, there was actually assembly language in the code for a little while, but we, in the terms of doing a non-operation and for the timing.
Well, I'm hoping, like, in the way that it works is that it just provides a richer set of features, and then from a beginning to advanced point of view, just being able to pull those features into it, so you're not really having to be too low level in getting that rolling.
Yeah, and it is right now we haven't written it into a library. We're planning on doing that, and we're also planning on implementing the whole Saab architecture on FPGA so we can get it direct to silicon.
Oh, cool. Cool. So I love the fact that with this book, a lot of the ideas are pretty solid, and then they all lead to some project down the line.
Yeah.
You can use this technique, and like you just mentioned, like you learn this technique, and then you say, okay, well, I've got this idea that I can do with an FPGA, and then we're talking compatible types of thinking. Anyway.
Yeah, and I think that's one thing I really want to mention was that for a lot of the chapters of the book, it was far more concept based than it was for this is the project you're going to make with doing this. It's no, here's another skill, here's another technology, one of the IP blocks on the Atmel chips or other variants that you were working with, that you really learn something from the chapter that you can apply towards whatever project the reader's going to come up with. And I know particularly Dan worked very hard on trying to make that happen. What exactly gave you the idea that was the direction to go instead of like a typical project book?
Well, pardon me, I never quite liked the project book. They always seem to be focused on here's how to make the project and never like say here how to expand further with your idea. So per Arduino, I kind of wanted to build it as here's a toolkit. I mean, I have a lot of books. I mean, I have like The Art of Programming by Donald Knuth, and that's a like classic reference of mine because it's not a project book. It's not like here's how to program C, here's how to program this. It's here's how to program. Here's how to do it in the back of the napkin. Here's how to develop an algorithm. It doesn't actually focus on the code whatsoever. So I really wanted to focus the book, or at least my chapters, on more of the concept stuff. Simulating sensors. Where you don't...
Oh, yeah. Can you talk more about that? Because that's a cool thing.
Yeah. No, I mean, on that chapter, I went out and, like, got code from other people that, already used the sensor. So they, online, their code worked with the actual sensor itself. And some of these sensors I didn't even have at the time. So I'm like, okay, cool. So if I can get their code to read my input, what I'm going to spit to it, and their code works as expected as the sensor, that was, really cool way of doing it. And it's also a nice way to test things. So you're able to pump data in that is good.
Right.
So if the sensor's, bad, you at least have a way of testing it in, physics, because there's not a direct, a lot of people don't have, oscilloscopes and they can't hook this stuff up. So there's other methodologies for debugging.
And I think that actually goes back.
I think that's just, that's really like on topic for this too, because I was trying to show, you can test things, but the other part is you have to sometimes simulate stuff so that you can have your test, because there's just you don't have the real world pieces of you don't have all the information or the right tools to say like here it is live. But if you can know that your data is working, and then you can say, okay, given these expectations, you can verify.
Yeah, how's my bot going to perform? I know we did this with a flight management system we've been working on for a glider, and we've been plugging it into a flight simulator and stuff like that. And so we're feeding our board real sensor data out of a computer to test to see if the thing will continue doing what it's supposed to do in the actual hardware.
Yeah, and then I'm actually going to be using something just like that in a self-driving car project, where we're actually working on the simulator side. And we're trying to say, okay, this car's got all these sensors, all this information, but now I got to put it in a virtual environment, this game engine, and really feed it data and have it do things that seem like it's behaving like a real car would.
Yeah.
Or at least in terms of what you need to know for self-driving. So I'm glad you wrote that chapter.
Yeah, I got to thank everybody on that chapter who had code available and provided code. I know there was a couple people out there that I went out and asked and got their code so I could put it in the book, and then I modified it as far as like comments and formatting just to kind of clean it up. Other than that, it's their code right off their websites.
Mm-hmm.
So
cool.
So in that regard, I think the community is already a little bit behind the project in that way, and that we involved what people were already working on, what people were interested in, hopefully.
So you can go off into those projects and dig down deeper.
Yeah.
Or participate. That was actually one of the other things I wanted to make sure of was people. You get a project going, you want people to participate in your project. You want to encourage that, but as much as that, you want them to use your project in a particular book, or get the information exchange going and build the communities. And that's, starting out writing sketches is a great way to learn, but trying to say, how do I make that communication happen? How do I build the community? How do I create the community for the product even?
Yeah.
You have to pull all that together. And that's one of the reasons I also added that library chapter, was that after a while, you're like, okay, I want to do code reuse, but not only want code reuse, I want other people to use my code in a project.
Yeah.
And that makes it come alive, and then it makes reuse better. So when it comes to using that's why I went after that libraries chapter.
Yeah.
So we did like how to do it in C, how to do it in C++, and then I do an example of reading a data sheet and implementing a library around what was told in the data sheet. And I think that was one of those key things, is to write a library. You can sit down with a data sheet, read through it, and then extract what it actually does, and then break it down into the logical components that you would want to use, and then hide essentially the complicated pieces that is the reason you're writing a library.
Yeah.
Is to make it easier for people. So
you just have that interface that people have the ability to, just use it, and that makes it really nice, without having to dig into the code or have like this massive long list of code in their code every time. Copy paste is a wonderful way
copy paste
of reuse, but if you have a library, you have the functions, you just know, I pass this here, I get this back. That's all you need to know. Granted, there is sometimes a problem with libraries that they can be too big, or poorly coded, but that's
and you have to make a decision. Is this like a C style library, or is this a C++ style library?
Yeah.
And when he talks about memory management, you have to make you have to really think through what kind of trade-off you want to make.
Mm-hmm.
Because especially on the Atmel chips, the AT Tinies and these other families, you collect memory, but you don't give it back.
Yeah.
There's no memory management at all. So in that case, you have to be very careful in your design.
Yeah.
And so in this, so I basically at least show a few options that, all right, if you just want to get the job done and use as little memory as possible, this is a C technique of just grabbing your functions and stuffing them in a library. And here's how you shoehorn it into the Arduino IDE so that you can make a library to get started in the environment that you started writing your sketches.
Yeah.
That was a little tricky, but that's all in there. So
yeah, I've been working on trying to get like code blocks or some other IDE to kind of be a little more friendly with like the Arduino way. Press compile and it runs. But I mean, there's sometimes with the libraries in Arduino, you can't like link other code and go, where does this come from?
Right.
So
actually, I mean, thinking of like this kind of leads because I've been working really hard on the ChipKit project, and this friend of mine, Mark Sproul, and I we did a lot of collaboration together. And what we did was we took we looked at, he'd been porting a bunch of AVR chips, the entire AVR family, over to Arduino, and then we got asked about the PIC32, and so Mark actually took the idea of what he'd been doing, porting every single chip possible to Arduino. We looked at the PIC32 pieces, and that's where I implemented his design, and now that design's not just in the ChipKit version of Arduino compatible, but Arduino 1.5 has got that same technique in it. So the abstraction technique is finally there, so that in the latest generation, you can actually include tool chains for different chips, and then set up libraries that are very compatible with Arduino, and just drop down, list, choose different chips.
Yeah.
So
that's pretty exciting that that's in there.
Actually, I know what they've been using. Let's see, was it the one? Oh. There's a 128 chip out there. Less pins than the 256 mega chip that a lot of people have been using lately. It's slightly more pins than an Uno or a Leonardo, but gives you more memory space.
Mm-hmm.
And doesn't give you all the pins that you have on a mega. Because sometimes a mega is just overkill.
Yeah, I mean that's exactly it. You're like, if you're doing a project that takes a bunch of inkjet heads and you're coordinating them, you need lots of I/O. But sometimes what you really need are maybe 6 pins total, and that's that. And if you tune it just right, you don't need the base cost of your project to be $35. You can get that price dropped way down. And that was the other part of this book, was to think about, if you've got all these options, pick the right board at the correct price point for a product that you would sell. And there's places like Tindy and all kinds of places to sell your open hardware designs. But the trick would be is, why build in an exorbitant cost that you want to build in it you want to bring that cost down, because when you do distribution, the distributors are easily going to try to charge 3 times your base cost.
Yeah.
Easily that.
Oh yeah. Oh yeah.
So you might go, I got a $35 project. Well, it turns out you can't sell it for less than 70.
Yeah, it's always a markup of 300%. I mean, that's usually the way you got to look at it.
So then if you can drop it down to 12, now you're at least at 36.
Yeah.
So it's really interesting trade-offs. But I wanted to make sure at least the fundamental tools were there to give you, the developer, option to say, hey, well, I want to try this chip out.
Yeah. I know one thing I kind of done, and this kind of follows back to How to Make Your Own Electronics Lab book. I forget who did that book, but it's another A-Press book. Before that book came out, it's about reuse. So not only in the software realm of reusing, but in the hardware realm of reusing. Everything should be a breakout board. I mean, I don't care for shields as much, but so it should be a breakout board that you can be able to go from one style chip to another and grab the sensor you need. So, like, I have the Adafruit SD card adapter that has the level converters and everything. It's not the shield, but I mean, I'm able to plug that into the Uno, the Mega, the Fubarino, the BeagleBone, all those boards. I'm able to just hook that up with some jumper wires. But if it was a shield, Like I know the
Mhm.
Gameduino, and I talk about it in the game development chapter.
Oh yeah.
That you can hook the Gameduino up to the Mega through the SPI. And a lot of
Mhm.
people have just done a software bitbang SPI to be able to plug the shield directly in.
Yeah.
And that slows it down a little bit. So, there's a way of just hooking it in directly, and you still have that same access. Like I'd love if the Gameduino was just a breakout board.
I mean, that's actually a really good suggestion or a variation. I hope they're listening and they'll
Yes.
Yeah, hopefully, Game
But,
Duino gets a little bit of love here. So
Yes. It's a
Yeah.
phenomenal little graphics card for the Arduino. I mean, it's like an NVIDIA.
or really
GTX.
any other microcontroller that runs SPI. I
Yeah.
mean, it's pretty
Yeah.
versatile in that
well,
regard.
I
So,
think also in the time that the book sort of was generating, we actually ended up looking at what was the story? The SPI, the Arduino revision 3 of the hardware format came out. So they moved the I2C pins off of the A0, A1, or A6, A5 and moved it over to like the lower right hand side. So at least the new Megas and the new Arduino Unos have I2C in the same place.
Yeah, but
So there was
I2C's a little slow.
some of that, like that happened during our book.
Yeah.
Was like all of these various changes.
So, I mean, it's, definitely been a fun book to write and, get out of the way. I, suggest readers, pick it up and at least check it out, maybe try a couple of projects. So, yeah, it's kind of, I mean, there's a lot more we can talk about, but it's kind of getting that time, so.
Yeah, I think that it would be fun to over time explore into some of the things we did for the chapters and maybe eventually talk about some of the things we're planning to do post that.
Yeah.
I think just getting the book out is just the beginning of the conversation we're starting with all these people.
Oh, yes.
So I think I'd like to just ask one quick question of both of you. Is if you were to give one reason to go ahead and make that leap and push the buy button on the book, what would it be?
You're buying a tool. I mean, it's really it's going to be something that's going to be in your kit that you can use as reference. I mean, I've used it as reference. I wrote half of it, and so it's I've used my own chapters as reference. Like how did I do that again? But I mean,
I totally agree with you on that. I go back to my chapters as well because there's pieces in it that I was like I put it there because I needed it.
Yeah. So, I'm gonna say let's crack the drink that we've been holding on to since the book started, and have a little toast. So
we hope it hasn't gone bad.
Yes.
So
our flavor of drink is the Balls energy drink. So
well, I have a classic mellow yellow over here.
Okay.
it works. So
There we go. Hey,
Huzzah.
cheers, guys! I really appreciated working with you. And we'll do more of this.
keep this continuing. So
That's right. And we get to look at more crazy technology.
yes.
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 So we
So
wish you luck.
anyway, y'all have fun.
Yep. Have a good one.
All right, talk to you later.
That's it for today. This has been All the Ideas. Check out Pro Arduino, available at Apress, Amazon, and the Madfellows blog at madfellowstech.com.